In February 2012, pro skier Elise Sagsted was carving through the slopes of the Cascade Mountains when a crack formed in the snowpack above her. Before she was fully engulfed by a 5,000-ton wall of snow, Elise heard "avalanche" just in time to react with a life-saving maneuver. So how could she survive this crushing snow surge? Avalanches are the rapid descension of snow, ice, rock, or a combination of these down a slope. They can be destructive natural disasters and personal tragedies. In the United States alone, avalanches kill an average of 27 people annually. These alpine nightmares don't just awaken out of nowhere. They need 3 specific conditions. First, the mountain needs to have the right slope, typically between 30 and 45 degrees. This is shallow enough to allow snow to build up on the slope, yet steep enough to provide enough potential energy for movement. Second, they typically need a layer of sturdy snow deposited over a weak or unstable layer, or what's sometimes called something over nothing. Take the Cascade Mountain avalanche, where recent heavy storms deposited a nearly 1 meter deep slab of fresh snow. Below this sat a thin layer of surface hoar. These are delicate, feathery ice crystals that form when water vapor in the air rapidly freezes on the surface of snow, almost like dew in the wintertime. Finally, avalanches need a trigger, something to collapse the weak layer and put the snow in motion. A trigger can be natural, such as heavy snowfall, strong winds, rainfall, or even other avalanches. Or they can be human-caused, like the surface impact of skiers or snowmobilers. Since fractures can propagate quickly through the snowpack, triggers can originate hundreds of meters away, upstream, downstream, or even adjacent to the avalanche's path. Once in motion, how quickly an avalanche moves depends on the slope's steepness, its exposure or vegetation cover, terrain roughness, and the type and amount of snow involved. For example, dry, light, and loosely bonded snow tends to travel fast, forming a powder cloud as it moves. In contrast, wet snow avalanches, caused by water moving through the snowpack, travel more slowly, but are much denser and can be particularly destructive. Larger avalanches can travel more than 160 kilometers per hour, breaking trees, destroying buildings, and burying roadways. In 1970, one particularly massive avalanche, consisting of 50 to 100 million cubic meters of glacial ice, snow, mud, and rock, reached speeds of over 300 kilometers per hour. This avalanche proved to be the deadliest in history, engulfing an entire Peruvian town and killing 18,000 people. Avalanches aren't always this large, but even smaller ones can be dangerous for anyone caught in their path. As snow rushes downhill, it can behave like both a solid and a liquid, making its movement difficult to predict. At the fastest moving front, surface snow moves faster than the snow beneath, pulling victims deep into the snowpack and scattering them across wide areas, making rescue difficult. Once an avalanche slows, the snow loses its fluid-like properties and compacts, leaving victims immobilized and unable to escape on their own. For these reasons, the best way to survive an avalanche is to avoid one altogether. Thankfully, at most ski resorts, parks, and even highways, avalanche workers mitigate risk by continuously monitoring the weather, stability of the snowpack, and human activity. If a threat is detected, they'll close terrain and may even intentionally trigger a controlled avalanche with explosives or artillery. However, there are regions where avalanche risk is not actively mitigated, known as the backcountry. Here, you are responsible for managing your own risk. Local avalanche centers provide avalanche forecasts, and anyone entering the backcountry should understand them, be properly trained, and carry essential rescue gear. And ultimately, in high-hazard terrain, there's no way to completely eliminate risk. The group at the Cascade Mountains consisted of highly experienced skiers, yet the area was very exposed, and following a large storm, the avalanche danger forecast was elevated. In the end, 3 skiers lost their lives, but not Elise, as she was able to deploy an inflatable airbag. These devices are imperfect, and a last line of defense, yet can keep a victim closer to the surface, improving their chance of rescue should disaster strike. Ready to keep learning? Watch these videos to either challenge what you think you know or learn more about what you don't. Subscribe and stay curious.